Hello friends, today we are going to show you how can you write the chemical formula of any compound. So without wasting time, let's get started. So first of all, the thing is that you have to know the list of some common electrovalent positive ions or basic radicals and the list of some common electrovalent negative ions or acidic radicals. So both the tables I am going to give you in the description link so you can go through them. So without wasting time, let's get to the first step. The first step is to write the symbols side by side of the elements and of the basic radicals and the acidic radicals. First of all, you have to write the symbol of the basic radical in the left side corner, and you have to write the symbol of the acidic radical in the right corner. So let's write something. First, I am going to give you the example of magnesium chloride. First of all, you have to know that what is the atomic number of magnesium. So if you will go to the periodic table and you will see the atomic number of magnesium, you will see that it is at the 12th number. So means its electronic configuration because of the 2n square rule would be 2, 2, 8 and 2. The electronic configuration of magnesium is 2, 8 and 2. So it is important to know what is the electronic configuration for writing, as everything depends on this only. So as you can see that in the valence shell there are 2 electrons left. So it is not completing its octet. So for completing its octet, it have to share 2 electrons to the another element. So if and you have to know that if there are 1, 2 or 3 electrons in the valence shell, then the element will leave electrons, and if there are more than 4 electrons in the valence shell and less than 8, then they will gain electrons. So here you can see that there are 2 electrons in the valence shell. So here what we have to do is that we have to write Mg will leave 2 electrons, as its electronic configuration is 2, 8 and 2. So it will lose 2 electrons to complete its octet. So if it loses 2 electrons, it will become Mg2 plus. As it becomes Mg2 plus, you can see that it has become a positive ion or a cation. So you have to make it a cation. So its valency is 2. And then you have to write the valency of the acidic compound. So if you go through the list, you can see that the valency of chloride ion is 1, means Cl minus 1. So first we have to write both the valencies with their names, symbols, and here I have to write Cl 1 minus 2 plus. So here you can see that both the valencies have been written, and the second step is to ignore the plus and minus symbol of the radicals. It doesn't matter whether it is, so I can erase this. The main thing is this 2 and this 1. You have to keep it in mind. The third step is to divide the valency number by their highest common factor, HCF if any, to get the simplest ratio. So here it is nothing, it is 2 and 1. So they will not be divided by any of the number. Then if it will be 2 and 2, then they will be divided by, and they will be cut and they will get 1 and 1. But there are nothing like that. So the fourth step is to interchange the valency of the radicals. So it's here you can see the valency of magnesium and 2 and of chlorine is 1. We have to interchange the radicals. If we interchange the radicals, Mg will become Mg1 in subscript and Cl2 in the subscript. So here you can see that it has become Mg1 and Cl2. After that you have to not do anything and just you have to write the chemical formula. I am deleting everything. First of all, let me delete, and I have to write the chemical formula, which is MgCl2. So this was an easy example. So let's move to the second example, which will be a bit harder than this. Second one will be aluminium hydroxide. So the atomic number of aluminium, if you go to the periodic table, you will see that the atomic number of aluminium is 13. So its electronic configuration is 2, 8 and 3. 2, 8 and 3 is the electronic configuration. So as you can see, there are 3 electrons in the valence shell. 1 minute, what happened? 3 electrons in the valence shell. So they will lose 3 electrons, means they will share 3 electrons to the another element and will be complete its octet and become a cation. So here I can write that Al minus 3 electrons is equal to Al 3 plus. As you can see that it has been a cation. And then I am going faster, that if you will go to the second table which I have shared, which is the list of the common electrovalent negative ions, you can see that the hydroxide's valency is 1, OH minus. So here you can see it is OH minus. So we have to write them side by side. First we have to write the acid one, Al3 and OH1. OH whole one, because they are overall. So you have to interchange their valencies. After you will interchange their valencies, it will become Al1 and OH3. It has become OH3. So after it had become OH3, it has done. You have to just write the chemical formula, AlOH3. Do you think it is right? No, because if you have interchanged the valency number to the lowest right of the radical, and if the radical is a group of atom and has a valency number more than 1, then you have to enclose it within a parenthesis. So here you can see that it is 3 and OH is combined, that it is not that H is different, O is different and Al is different. O and H are both similar, then you have to give O and H in a parenthesis. After you give them in the parenthesis, it is done. AlOH whole thrice is the chemical formula of aluminium hydroxide. So I hope you guys understood this. So if you guys like the video, please like it and subscribe to our channel. Meet you guys in the next video. So goodbye till now.